Have you ever wondered what powers almost everything around us? What is this invisible force that can spin a machine fast enough to literally move the world? Today, we're going on a journey to uncover the story of the genius often called the father of the electric motor. He's the man whose incredible invention changed the entire course of history. Yet most people have never even heard his name. How could one simple discovery, almost by accident, become the very heartbeat of modern civilization? Let's find out. Our story begins way back in the early 1800s. It's a time of flickering gas lamps and horse-drawn carriages. As he demonstrates the power of a new phenomenon called electricity, he notices something truly remarkable. A small compass needle, sitting nearby, suddenly twitches and moves every time the electric current flows through a wire. It was a complete accident, but it revealed a hidden truth of the universe. Electricity creates magnetism. This single observation sparked a firestorm of innovation across Europe. Inventors and scientists immediately began to ask the next logical question: if electricity can create a magnetic force, can that magnetic force be used to create motion? The race was on. Scientists like André-Marie Ampère in France began meticulously studying the forces between the electric currents, while in England, the brilliant Michael Faraday started exploring what he called electromagnetic induction. These early discoveries, this chain reaction of curiosity, laid the essential groundwork for making electricity do physical work, for making machines move all on their own. With this newfound knowledge, inventors everywhere began tinkering. They started building strange contraptions, experimenting with coils of wire placed inside magnetic fields. What they discovered was an invisible push, a force we now call the Lorentz force. It wasn't just a tiny twitch like Rysted's compass needle. This was a powerful, tangible force, strong enough to make a coil of wire spin with incredible speed. Imagine holding a loop of wire, and with the flick of a switch, it's suddenly pushed by an unseen hand, rotating on its own. This was the fundamental principle, the very soul of all electric motors. Of course, the first motors were crude, noisy, and sometimes even dangerous. They sparked and sputtered, but they proved one monumental thing: humanity could now convert electricity into continuous, controllable motion. The door to our modern, automated world had just been kicked wide open. So, how does a modern motor actually work? Well, a standard DC motor, the kind you'd find in countless devices, is surprisingly simple in its design. It has four main parts. First, there's the stator. These are stationary permanent magnets that create a fixed, constant magnetic field. Think of them as the outer ring that everything else happens inside of. Second, you have the rotor, also called the armature. This is the part that spins, and it's essentially a coil of wire wrapped around a core. Third, and this is the really clever bit, is the commutator. It has a special rotary switch attached to the rotor that reverses the direction of the electrical current at just the right moment. And finally, you have the brushes. These are small contacts that physically touch the commutator, delivering electricity from the power source to the spinning rotor. Here's how they all work together. When current flows through the rotor's coil, it becomes a temporary electromagnet. This new magnetic field interacts with the stator's permanent magnetic field. One side of the rotor coil is pushed up, while the other side is pushed down. This push creates rotation, and the motor starts to spin. But here's the problem: without something to manage the current, the rotor would just spin halfway and then get stuck, locked in place by the magnetic forces. That's where the commutator's genius comes in. Just as the rotor reaches that stopping point, the commutator flips the direction of the current flowing into the coil. This reverses the rotor's own magnetic field. Suddenly, the side that was being pushed up is now pushed down, and vice versa. This clever switch ensures the push is always in the right direction to keep the spin going. It's like pushing a child on a swing. If you time your pushes perfectly, the swing just keeps going higher and higher. The commutator provides that perfect, continuous push, allowing for smooth, uninterrupted rotation. Now, let's talk about the sheer scale and impact of this invention, because some of these facts are truly shocking. Did you know that over 50% of all electricity generated worldwide is used to power electric motors? That's more than half of our global energy supply dedicated to making things spin. The tiny, brushless DC motors in your phone are what make it vibrate. When we look at electric cars, their motors can achieve almost 95% efficiency. That means nearly all the electrical energy from the battery is converted directly into motion, which is why they are so much more efficient than gasoline engines. And in the industrial world, powerful motors can spin faster than a Formula One engine, some reaching speeds over 20,000 RPM. Think about it, without electric motors, there would be no elevators, no air conditioning, no drones, no power tools, no modern factories, no space exploration. Almost every machine that defines modern life relies on this principle. Every single rotation is a quiet reminder that one simple discovery truly powers the entire world. What began as Rosted's simple, accidental classroom experiment truly became the heartbeat of modern civilization. From the very first industrial factories that replaced manual labor with machine power, to the advanced robotics labs building the future today, the electric motor has enabled unprecedented levels of productivity, comfort, and innovation. The visionary inventors who took that initial spark of an idea and built the first motors, people like Faraday, Ampere, and many others, laid the foundation for our entire technological age. Their work, often done in humble labs with basic equipment, continues to shape every single corner of our daily lives, usually completely unnoticed. Every time you ride an elevator, use a kitchen blender, see a robotic arm on an assembly line, or benefit from a modern medical device, you are witnessing the legacy of their curiosity in action. And here is the most incredible twist in this whole story. The fundamental principle discovered over 200 years ago is still the driving force behind our most cutting-edge, futuristic technology. From the autonomous drones that can navigate complex environments all on their own, to the development of electric airplanes that promise a new era of clean flight, to the advanced robotic prosthetics that can restore movement with lifelike precision. All of these innovations rely on that same basic interaction between electricity and magnetism. It is absolutely amazing to think that one classroom observation with a simple compass needle became the foundation for all of this. The spirit of that initial discovery is alive and well, continuing to push the boundaries of what's possible. So, who was the true father of the electric motor? The answer isn't one single person. It was a relay race of geniuses. Rosted lit the spark, Faraday and Ampere fanned the flames, and countless others built upon their work to create the world we know today. Every spin, every rotation we see around us is a constant reminder that one small discovery, one moment of pure curiosity, can genuinely change the world. If you loved this deep dive into the hidden history of the electric motor, make sure you hit that subscribe button for more short documentaries just like this one, and let us know in the comments below, which invention story should we explore next? Thanks for watching.